It's important that we also know how to find the slope of a line from a table of ordered pairs. Now, I want to preface by making sure we understand that just because you have a table of ordered pairs does not mean that all of those points are going to necessarily lie on a line. So then it wouldn't really make sense to find the slope of a line if it's not a line, of course. But for these particular examples, I did state that all of these ordered pairs do lie on a line, so it'll make sense in all these examples that we can find the slope of a line since these ordered pairs all do lie on the same line as one another. So for our first example right here, our goal is to be able to find the slope of this particular line. So we know that slope is, of course, rise over run. And since we're dealing with ordered pairs, we probably want to revert to the fact that slope is the change in the y's over the change in the x's. And so it does, as we've discussed previously, it doesn't matter which ordered pairs you choose in the line. So I could choose any of these 5 ordered pairs that I want. I'll just choose the first couple right here. So like this could be your first ordered pair, this could be your second ordered pair. So it does turn out that if you find y2 minus y1 first, it's really just like, okay, if I start at -2 and I go to 3, that's increasing, so it's like plus, and it's actually an increase of 5. So that right there is actually the rise, because it's the change in the y's, the change in the heights. And then if you go in this direction, that is going to find x2 minus x sub 1. You're starting at -3 and you go to -2. That's an increase because you're going upwards from -3 to -2. It's an increase of 1 unit, and that would be the run right there. So it turns out that the slope that we found right there is actually going to be 5 over 1, which reduces down to 5. So that's going to give you the slope of that particular line right there. And so you'll kind of see that throughout. So like in this example right here, you've got an increase of 2 in the run and a decrease of 3. And it turns out that that pattern persists all the way through, that you are increasing 2 in the x and then decreasing 3 in the y. So when you give the slope, then make sure that you always have the rise over the run. So the slope there would be -3 over 2. Now there's going to be some cases where the points you're given in a line aren't necessarily evenly spaced with one another, and you can see that through this example right here, where you can see there's an increase of 4 in the x's, and then an increase of 2, an increase of 6, and then an increase of 7. And if you look at the changes in the y's, you've got a decrease of 4, another decrease of 2, a decrease of 6, and then a decrease of 7. So if you find the rise over the run, you'll get like -4 over 4 in that case, or a -2 over 2, -6 over 6, or a -7 over 7. But it turns out that all of those, of course, just reduce down to -1 for the slope. It just happened to be that the points, weren't evenly spaced with one another. And then in this example right here, if you find like the change right here from 1/2 to 2/4, well, 2/4 is actually a half, right? So that's like a change of 0, of nothing there in the x's. And then right there to go from -3 to 0, that's going to be a change of +3. So when you do the rise, it's actually a +3, and then the run is 0. And then when you have 0 on the bottom, it's actually undefined. So it does turn out that each of these 5 ordered pairs right here, they're actually ordered pairs that are just like stacked on top of each other. It just makes a vertical line and gives you then, of course, an undefined slope.